Section 10.2 is calculus with parametric curves. So we go back and revisit. The first thing we find is that in order to find dy over dx, we find dy over dt, and then the denominator is dx over dt. This is if dx over dt does not equal 0. So we work with the parametric equation, and this is our formula here. So let's consider the following problem. It's problem number 2. It says x equals t e to the t and y equals t plus sine t. So if we want to find the derivative, dy over dx, the derivative of y with respect to x, first of all, in the numerator we take the derivative of y. So the derivative of t is 1, and the derivative of sine of t is cosine of t. So we take the derivative of y with respect to t. That's what this says up here. And for the denominator, we take the derivative of x with respect to t. So when we look at the denominator, we're going to use product rule. So we keep the t, and the derivative of e to the t is e to the t. And we keep the e to the t, and the derivative of t is 1. So we could simplify this and factor in the denominator, t plus 1, and the numerator is 1 plus cosine of t. It's really not difficult, except that you need to remember your calculus. The next set of problems say find the equation of the tangent to the curve. So we're finding the equation of the tangent to the curve. And we are given, for number 4 in your book, we're given x equals the square root of t, and y equals t squared minus 2t, and t equals 4. Remember this t equals 4 because to find the equation of the tangent line, you need the slope and a point. And the slope comes from your derivative, and so we need a point. Let's go ahead and find that point. When t equals 4, x is the square root of t, which is 2. And when t equals 4, y is t squared minus 2t. So y is 16 minus 8 is 8. So then we find the derivative. The slope is dy over dx. And in parametrics, the derivative of y is the dy over dx. The numerator is the derivative of y with respect to t. So we have 2t minus 2. And in the bottom, we have the derivative of the square root of t. That's t to the 1/2. So this will be 1/2 t to the minus 1/2. So let's simplify. So we have 2t minus 2 in the numerator. And this becomes 1 over 2t to the minus 1/2. So let's do 2t minus 2 times, flip, 2t to the minus 1/2. So that means we end up with 4t to the 1/2 minus 4t to the minus 1/2. So this really is 4 square root of t minus 4 over the square root of t. So now let's look at it at t equals 4. So our slope is going to be 4 times the square root of 4 minus 4 over the square root of 4. So 4 times 2 is 8, and 4 divided by 2 is 2, so our slope is 6. And we have the point 2, 8. So we're going to say y minus y1, which is 8, equals 6 times x minus x1, which is 2. So we have y minus 8 equals 6x minus 12, y equals 6x minus 4. So that's the equation of our tangent line. Now we could look at the graph and look at the line tangent to the curve, and it'll all be wonderful and beautiful, and life is good. So let's look at another example. Again, it says the equation of the tangent line. And it says x equals e to the t sine of pi t, and y equals e to the 2t, and t equals 0. So let's start with that t equals 0. When t equals 0, we have sine of pi times 0, and pi times 0 is 0. So sine of that is 0, times anything is 0. And e to the 0 power is the number 1. So now we can look at dy over dx. The derivative of y with respect to t is e to the 2t times 2, chain rule. And then when we take the derivative of x, notice we have product rule here and chain rule. So the derivative of e to the t times sine pi t, we keep the e to the t and take the derivative of sine of pi t. Sine of pi t is cosine of pi t times, and the derivative of pi t is pi, plus we keep the sine of pi t, and the derivative of e to the t is still e to the t. So let's simplify. And the numerator is 2e to the 2t, and the denominator, let's factor out a e to the t. We have pi cosine of pi t plus sine of pi t. Now we can cancel those e to the t's, one of them. So e to the, when you multiply like bases, when you divide like bases, you subtract exponents. So this means we get e to the t, just in case you didn't see it. So this means we have 2e to the t, and in the denominator we have pi cosine of pi t plus sine of pi t. Now remember t is 1, so, t is 0. So 2 times e to the 0 is 1, and then we have pi times cosine of pi t. Cosine, pi times 0 is 0, and cosine of that is 1, plus sine of 0 is 0. So we end up with 2 over pi. So we can find our equation of a line. Let's say y minus 1 from our point at the top. And then our slope, which is 2 over pi times x minus our x value at the top is 0. So y minus 1 equals 2 over pi times x. So y equals 2 over pi times x plus 1. So that would be our equation of our tangent line. So let's talk about a second derivative. So let's make a note here. We know that dy over dx equals dy over dt over dx over dt. And we call it dy over dx. So to find the second derivative, we take the derivative of dy over dx, and then we divide it by the derivative of x with respect to t. So you need to make note of that. So the next problem says find dy over dx, find the second derivative, and then find where is t concave up. Now remember that comes from our second derivative test. So let's start with the first derivative, but the problem is number 12 in your book, and it says x equals t to the third plus 1, and y equals t squared minus t. So the first derivative, dy over dx, equals the derivative of y with respect to t is 2t minus 1. The derivative of x with respect to t is 3t squared. So now we can find the second derivative. Now remember the fact that the second derivative means we're going to find the derivative with respect to x of dy over dx, and then we're going to divide it by dx over dt. So the derivative of that fraction, now this isn't L'Hopital's rule, so let's look only at dy over dx. So the derivative is the bottom, which is 3t squared, or low d high. The derivative of the top is 2t. 2t minus 1, and the derivative is 2. minus the high, which is 2t minus 1, times the derivative of the low, which is 6t, all over the derivative of the bottom squared. So this becomes 9t to the fourth. And then we put dx over dt in the denominator. So the derivative of x with respect to t, x is t to the third plus 1. So the derivative of that is 3t squared. So let's look at the top. In the top, we distribute that and we get 6t squared minus 12t squared plus 6t over 9t to the fourth. Keep change flips, so we're going to multiply by 1 over 3t squared. So let's simplify the numerator and the denominator. So the numerator becomes 6t squared minus 12t squared is negative 6t squared plus 6t. And the denominator becomes 27t to the sixth. Now notice t cannot be 0, so that restricts our domain. Let's simplify this further so we can factor out a negative 6t, and we're left with t minus 1, and in the denominator we still have 27t to the sixth. Now this will cancel to make these t's t to the fifth, and then 3 goes into 6 2 times and 27 9 times. So we really have negative 2 times t minus 1 over 9t to the fifth. And remember, still t does not equal 0. In order to check for concavity, we're going to look at our second derivative. Now we know that if the second derivative is positive, then our curve is concave up at that point. Remember, concave up is a little parabola, which means it's a minimum, but you don't need that part here. We're just looking for concave up or down. And if the second derivative is negative, then we are concave down. So we really only need to look at the second derivative here. So let's look at the numerator. We have negative 2 times t minus 1. So we want to look at the sign. Where is it positive? So let's set this equal to 0, or greater than 0. So t minus 1 is less than 0. When you divide by negative 2, you flip the inequality. So that says t is less than 1. So that's the first part. Now we need to look at this is for t to be positive. For concave up. And then we need to look at the numerator. For the same thing, t is positive. We have 9t to the fifth. And this happens, we want to look at where t is positive. And so t to the fifth is positive and t is greater than 0. So that means our concave up happens between 0 and 1 because it has to satisfy both of the requirements here. So our t is positive, t is concave up. Between 0 and 1. Now we have parentheses because at 0 and 1, on the numerator, if we have t equals 0, here we have a horizontal tangent line. So it's not concave up, it's flat. And here we have a vertical tangent line because the numerator is equal to 0, and that comes into play because t cannot equal 0. Now, before we go on, I like interval notation, but WebAssign may need you to say t is between 0 and 1 in that notation. Hopefully that's not a difficult switch. All right, let's look at number 14. Number 14 says x equals t squared plus 1, and y equals e to the t minus 1. So the question is the same. Find the first derivative, the second derivative, and concave up. So we start with the first derivative, dy over dx, and the derivative of y is e to the t, And the derivative of x with respect to t is 2t. Nice, simple first derivative. So let's talk about the second derivative. So we're going to take the derivative of that to be the quotient rule. Now when we take this derivative, we need quotient rules, so let's put a fraction up here. And we have the bottom, which is 2t times the derivative of the top, and that's e to the t, minus the top, e to the t, times the derivative of the bottom, which is 2, over the bottom, 2t, quantity squared, becomes 4t squared. And then on the bottom, we have the derivative of x with respect to t, and that's 2t. So this gives us, let's simplify the top. We have 2t, we can factor out an e to the t, and a 2. So we have a 2 e to the t, and we're left with t minus 1. And the bottom is 4t squared, and then keep change flip. So we end up with 1 over 2t over here. Now before we continue, these 2's can cancel. So we end up with e to the t times t minus 1 over 4t squared. So this is our 4t to the third. So this is our second derivative, and we know that t cannot be 0. And then our first derivative is back here because that's part of our answer. So to find concave up happens when our second derivative is positive. So if we take the numerator and say e to the t times t minus 1 is greater than 0, and then 4t to the third has to be greater than 0, that's both positive. But if we have e to the t times t minus 1 is negative and 4t to the third is negative, then both of those create a positive concavity. So we need to check both of them. Now over here, if we split this, e to the t is greater than 0 and t minus 1 is greater than 0. Now e to the t is always greater than 0 because that's what it is. So here we have t is greater than 1 and t is greater than 0. If you need steps in here, we divide it by 4, then take the cube root. So here we know when you put the two together as a conjunction, then t has to be greater than 1. So that's our first set of concavity, is when t is greater than 1 because it satisfies both of those inequalities at the same time. So first of all, we have t is greater than 1 or 1 to infinity. And now let's look at this side. Again, e to the t is less than 0. That's not positive, and that's not possible. It's positive, so it doesn't affect the sign of the other one. So t minus 1 is less than 0, so t is less than 1. And over here, t is less than 0. Now this only happens when t is less than 0. That's the overlap of the two inequalities. So not 0. So we have negative infinity to 0. So we have concave up from negative infinity to 0 and from 1 to infinity. So now let's talk about the area under a curve. If we were to say y equals capital F of x, notice that's the integral form and we were to look at the area from a to b, we would say the area equals the integration from a to b of f of x dx, where f of x is greater than 0. But when we look at this in terms of parametrics, we say x equals f of t and y equals g of t, and t is bounded from alpha to beta. Then we know that the integration, normally we have the area equals a to b y dx. So in this case, we're going to use the substitution rule, and we're going to change the variable to t. So we go from alpha to beta, and we're going to have g of t, f prime of t, dt. So it's kind of like triangles where you put in your substitution it comes in that form. It could be beta to alpha or alpha to beta, depending upon which one is the smaller. So notice that it's here we have the y, and in the second part we have the derivative of x with respect to t. So let's keep that in mind. We're going to say area equals the integration from alpha to beta, and we have g of t times f prime of t dt. The next problem says find the area under the curve of one arc of the cycloid. Now we looked at the cycloid in the last section, and it says x equals r times theta minus sine theta, and y equals r times 1 minus cosine theta. So that's what's given to us. So put it in your calculator and look at the arc of a cycloid, and we can figure out the bounds for t based upon that. One arc of the cycloid comes from one rotation of the circle, so we get that theta is between 0 and 2 pi. So we can say that theta is between 0 and 2 pi. So now we can integrate. We would normally say between 0 and 2 pi r, whatever that radius is, y, but we don't usually use y here. We usually use f of x dx. So this is the area under the curve. So this becomes the integration from 0 to 2 pi, and we have g of t, f prime of t dt. So let's fill that in. We've got 0 to 2 pi. G of t is y, so that means we have r times 1 minus cosine of theta. And then we have f prime of t. Well, f prime of t, let's do it down here. F prime of t is the derivative of x with respect to t. So the derivative of x with respect to t is, r is a constant, so we have r, and the derivative of theta is 1 minus the derivative of sine theta is cosine of theta d theta. We could say over here that x prime dx over dt, that may make more sense, dx over dt. And then we have d theta because by chain rule it's the derivative of theta. So then we have here times r 1 minus cosine theta d theta. So now we can say the integration from 0 to 2 pi. We have r times r, which is r squared. And we have 1 minus cosine theta, quantity squared, d theta. Well, that's not really something that's easily integrated. So let's say r squared, 0 to 2 pi. And let's multiply that out. So we get 1 minus 2 cosine theta plus cosine squared theta d theta. Now, some of that is easy to integrate. So let's say r 0 to 2 pi, 1 minus 2 cosine theta d theta plus r squared, or we could put a big bracket here and not put the r squared. Now, let's look at this last term. Cosine theta is 1/2. Cosine squared is 1/2 1 plus cosine 2 theta d theta. So this means we have r squared. Now when we integrate 1, we get theta, minus 2. When we integrate cosine, we get sine theta, plus 1/2, and when we integrate 1, we get theta. And then here we need to do the integration. Let's let u equal 2 theta, so du equals 2 d theta. So we need to use u sub in here. So here's the 1/2 from the parentheses, and then we have 1/2 cosine u, cosine u du. So we have r squared times theta minus 2 sine theta plus 1/2 theta plus 1/4. The integration of cosine is sine u. And we have bounds, so we don't need plus c. So we have r squared theta minus 2 sine theta plus 1/2 theta plus 1/4 sine 2 theta. And this is, the bounds are from 0 to 2 pi. Now the good news is the sine of 0 and 2 pi are both 0. So we end up with r squared times 2 pi minus 0 plus 1/2 times 2 pi is pi plus sine of that is 0. And then we're going to say minus 0. Sine of 0 is 0, 0, 0, 0. So that works out well. So we have 3 pi r squared. And that's the area of one cycloid. The next problem says find the area enclosed by the x-axis and the curve x equals t to the third plus 1 and y equals 2t minus t squared. So the first thing you need to do is graph that and look at what it looks like. So here I've added the graph, and notice we're going to stop at the x-axis. So in the x-axis, our y value is 0. So let's say y equals 2t minus t squared, which is 0. So let's solve for t. Let's factor out a t, and we get 2 minus t equals 0. So t equals 0, and t equals 2. So that means our bounds are going to be from 0 to 2 to find the area under the curve. Now the area under the curve is this area right in here. And you can see that when t is 0, x is 1. And when t is 2, x is 9. So that looks about right to us. And then we're going to put in our y, which is 2t minus t squared. And then we need to find dx over dt, which is 3t squared. So we're going to say times 3t squared dt. So let's distribute that, 0 to 2. We have 6t to the third minus 3t to the fourth with respect to t. So we can go ahead and integrate. When we integrate, we add 1t to the fourth, so 6 over 4 is 3/2 t to the fourth, nice easy integration, minus 3/5 t to the fifth from 0 to 2. So let's put in the 2. So 2 to the fourth is 16, times 3 is 48, divided by 2 is 24. And then 2 to the fifth is 32, times 3 is 96 over 5, minus, and both of those become 0. You should check that because it doesn't always happen. Common denominators of 5, or you can use your calculator. This is 120 minus 96 gives me 24 over 5, which is 4.8. So I think you have enough now to do this lesson. And remember, your key to your integration is the fact that you have the integral of g of t times f prime of t with respect to t. Thank you.